Courses in the cement industry. Present to you. In this series of courses, we will explain everything about circular stores. This course will explain definition and mechanical components. Course 1. The stacker is mounted on the center column, which allows rotation in both directions simultaneously, with the vertical movement of the jib. Reclaiming takes place at the natural angle of slide. A raking harrow is mounted on the bridge reclaimer, which rotates anti-clockwise around the central column. The sweeping movements of the harrow system cause the material to slide to the base, where the chain system then conveys it to the centrally placed outlet hopper. Circular storage. Description. Discharge from feeding belt conveyor, supported in a bridge structure, to the feeding chute of the stacker is provided directly. Stacking of the circular stockpile is effected by the stacking boom of the circular stockyard equipment. Transfer and discharge of the material reclaimed by the bridge reclaimer onto the outgoing belt conveyor is provided by means of a central discharge chute and a vibrating feeder. The bridge-type scraper reclaimer should operate outside the stacking section. Normally stacker and reclaimer work in automatic mode or manual, and repair operation are provided too. Continuous chevron. The circular store has a round base, with one pile being continuously stacked at one end and reclaimed at the other. Stacking takes place in a fan-shaped arc, typically 120 degree. With each sweeping movement corresponding to one layer of material, the whole sector moves approximately 2 degree ahead. Homogenizing store. Reclaiming takes place at the natural angle of slide. A raking harrow is mounted on the bridge reclaimer, which rotates anti-clockwise around the central column. The sweeping movements of the harrow system cause the material to slide to the base, where the chain system then conveys it to the centrally placed outlet hopper. The homogenized material leaves the store by an underground rubber belt conveyor, or any another conveyor, leading either to a hopper or direct to the raw mill. Specification of the equipment. 1. Central column. The central column is provided in welded steel construction of round rolled steel plates, with the necessary stiffening ribs. It has carefully aligned and treated supporting rings for the ball-bearing slewing rings of stacker and scraper reclaimer, as well as connecting equipment for the electric slip ring. The column foot is ending and supported on a supporting structure with 4 legs of welded steel plates. An upper connecting flange for the feeding belt conveyor bridge has been provided on the support structure of the stacker. One conical shaped discharge chute, as well as a vibrating feeder, equipped with wearing plates, are supported below the column foot. All necessary anchoring material for the central column foot is included. 2. Ball-bearing slewing rings. The slewing rings for the support of the feeding belt bridge and the support of the reclaimer bridge are designed as a one-row anti-friction bearing, which take all occurring forces and moments. The running systems are protected by special seals. Lubrication bore holes for the connection to the central lubrication system are distributed on the slewing ring. 3. Support structure for the stacker. The supporting structure is provided in welded plate and profile steel structure. With regard to the roller bearing slewing connection, it is designed especially rigid. The ring girders for the roller bearing slewing connections, and the support construction for the slewing drive is carefully aligned. The support structure comprises the access structures, with ladders, platforms, boom support construction, gratings, and railings. 4. Slewing mechanism for the stacker. The slewing mechanism mainly consists of the roller bearing slewing connection and one slewing drive unit. The slewing ring is designed as a 3-row anti-friction bearing with outside toothing and takes all occurring forces and moments. The running system is protected by special seals. Lubrication bore holes for the connection to the central lubrication system are distributed on the slewing ring. The slewing drive is supported on the slewing support structure and consists of brake motor, rotation flexible coupling, and special planetary gearbox. The pinion attached to the drive shaft catches into the toothing of the ball bearing slewing connection. The slewing device is additionally protected by a slew ring protection of metal sheets attached to the support structure. 5. Hoist device for the conveyor boom. Lifting and lowering of the conveyor boom is provided by means of one hydrostatic hoist device with hydraulic aggregate and hydraulic cylinder. The hoist device mainly consists of pump with motor and coupling, manometer, hose leads with screw connections, standard oil container, all completely mounted on an element frame structure, and piped with built-up control, piping with cut ring screw connection, the differential cylinder with link eyes at both sides, and with attached lowering brake valves. The complete hydraulic hoist unit is supported on the slewing support structure of the stacker. 6. Stacking conveyor boom. The boom structure is provided in welded steel plate and sectional steel construction, with gangways at both sides, consisting of gratings and railings of tubular structure in accordance with the safety prescriptions. At the tail end of the boom, one counterweight box is provided. The supporting of the boom is provided by link bearings on the support structure of the stacker, further it is held by the cylinder of hydraulic hoist device. The conveyor mainly consists of the following parts. The drive pulley in welded steel constructions, with diamond-shaped rubber lagging, the shaft supported in tensioning blocks, with anti-friction bearings. The discharge pulley and snub pulley, of same design supported in pillow blocks, the latter however with plain rubber lagging. The complete spindle tension device, with protecting grids. The 3-parted troughed idler stations, with life lubricated idlers, with anti-friction bearings and labyrinth sealing, supported on idler frames of section steel. The inclination of the outer idlers is 40 degrees. The 3-parted impact idler stations, with buffer idlers of similar design feature. The return idler stations, with supporting ring idlers, of similar design feature. The rubber belt with 4 layers, and plain rubber rim protection. The feeding chute with material guidance of plates, with changeable lining, and adjustable rubber bands. The cover plate in the area of the material feeding section between upper and lower conveyor parts. The spring lamellar stripper at the discharge pulley, and the plow stripper with adjustable rubber bands. The complete drive unit of the boom belt conveyor is consisting of geared motor, with fluid coupling, brake and dust and oil-tight hollow shaft gearbox. Undesired return run is prevented by a backstop. The drive elements are supported on a common welded base, which is connected by a torque arm with the boom structure. The conveyor also comprises all necessary protection devices and holders or consoles, for pull ropes, switches, rope probes, ultrasonic probes, speed watchers, belt skew run watchers. 7. Traveling chassis of the reclaimer. At the central column, the bridge type scraper reclaimer is supported by a ball bearing slewing ring. At the periphery, the scraper reclaimer is traveling on two fairly dimensioned traveling wheels. One of them is a driven wheel. The occurring axle loads are taken by anti-friction bearings, sealed by radial shaft seal rings. On the drive shaft of the driven wheel, one drive assembly is mounted, being additionally supported at the head girder, by means of a torque support. The driving unit is provided for traveling either with working speed, or with fast travel speed for traversing. We follow together, traveling chassis of the reclaimer. The travel drive for the working speed is provided by means of a frequency-regulated AC gear motor. For fast travel, the AC gear motor is disengaged by an electromagnetic switch coupling, and instead of this an AC squirrel cage motor with brake is engaged. For speed reduction, a dust and oil-tight gearbox is arranged between the common motor shaft and the travel wheel shaft. The head girder is leading the bridge loads to the traveling wheels. The torsion-free box structure, welded of steel plates, assures the durable direction stability of the traveling chassis, having been pre-adjusted in the workshops. The traveling chassis also comprises rail cleaning devices. 8. Bridge. The bridge structure has to support the harrow carriages, with its rails, as well as the drive unit for the harrow, and the complete scraper chain, with its guidance. The bridge is provided in welded box-shaped construction fabricated of steel plates, and with stiffening ribs inside. As a result of this design, the bridge is insensitive to dirt accumulation and corrosion. The end part of the bridge, at the central column, is designed as a fork link. In this part, the bridge is supported on two links upon a rigid ring girder around the column and bolt connected with the ball-bearing slewing ring. The connection of the opposite end of the bridge with the head girder is designed as a link. By this method, an even and correct load distribution is assured. The bridge structure furthermore comprises the walkways with gratings, stairs or ladders respectively, railings, support structures for the scraper chain drive, and the chain tensioning device. 9. Scraper chain guidance. The frame structure for the scraper chain guidance is designed in welded and bolted construction. The chain guiding tracks are designed in L-shaped structure in the upper guidance, and in U-shaped structure in the lower guidance, in order to keep dirt accumulation on the chain strands as low as possible. They are replaceable. 10. Scraper chain. The heavy double-stranded scraper chain is fairly dimensioned in all parts. Wearing in the link area is kept low by means of hardened bolts and bushes. The bolts are provided with anti-rotation locking and clamp rings. Each second chain link is equipped with a wear-proof scraper blade in welded normal steel plate structure, fixed by bolts and nuts. Teeth are provided at the cutting edges of the scraper blades. 11. Scraper chain drive. The drive shaft of the scraper chain is supported in strong and sealed anti-friction bearings. The chain sprockets are designed in welded execution. They are two-parted, and therefore are easily replaceable. The scraper chain is driven by one drive unit supported on a base frame, and consisting of AC motor, with fluid coupling, a dust and oil-tight bevel helical wheel gearbox. The complete drive assembly is arranged laterally at the bridge girder, and is supported against the bridge by means of a flexible torque support. 12. Chain take-up device. The chain return wheels are supported in sealed anti-friction bearings. The return shaft is oscillatingly supported in the tension carriage. The tension carriage is centrally arranged below the bridge, and is provided with Belleville cup springs. The tensioning of the chain is provided by a grease-filled hydraulic cylinder, with manometer for supervision of the chain tension. 13. Slope harrow. For steady reclaiming of the material from the slope of the pile, one harrow is provided. The harrow is manufactured as a welded structure of square tube profiles. The harrow is provided with raking teeth of steel, which are connected by bolting, and which can, in case of wearing, easily be projected and finally be replaced. By means of a manually operated rope winch, provided in a tower which is supported on the reclaiming bridge, the harrow can be adjusted to favorable operation position in accordance with the material to be reclaimed. The upper part of the harrow is suspended at the tower by means of galvanized ropes, running on rope pulleys. The rope pulleys of the tower on the reclaiming bridge can be reached via an access ladder. We follow together, slope harrow. The lower part of the harrow is supported on fairly dimensioned wheels, supported in anti-friction bearings. The harrow is moving on special formed rails, which are supported on the bridge girder, on a frame structure. The slope harrow is traveling slowly, and correspondingly safely and with few wear. It is driven by one hydraulic drive unit, supported on the reclaimer bridge. The hydraulic drive unit mainly consists of following components. 1. Pump aggregate with motor, pump and oil container with filter. 2. Tubes, valves, and fittings. 3. One amply sized cylinder with linked bearings, and chromium-plated piston rods. 14. Lubrication. One central grease lubrication system lubricates the harrow rails from outside. One central oil lubrication system lubricates the scraper chain from outside. The lubrication points of each slewing connection are combined over tube leads. They also are lubricated automatically by two central grease lubrication systems. Each lubrication system consists of the motor-driven pump with container, pipes, bolts, and necessary hardware, with connection and fitting materials. All anti-friction bearings are provided with life lubrication. In order to facilitate the renewing of the permanent lubrication, the bearings are provided with additional lubrication nipples. Some other lubrication points, with very low need of lubrication, are fitted for manual lubrication. In this section explain mechanical components of circular stores. 1. Incoming belt conveyor. He is responsible for the transfer of the limestone to inside the stone store. Discharge from feeding belt conveyor, supported in a bridge structure, to the feeding chute of the stacker is provided directly. 2. Jib. 3. Conveyor belt for jib. Stacking of the circular stockpile is effected by the stacking boom of the circular stockyard equipment. 4. Central column. The stacker is mounted on the center column, which allows rotation in both directions simultaneously, with the vertical movement of the jib. Five. Luffing unit. This unit responsible for, up or down conveyor belt jib. Its height above the crest of the pile, is kept at a minimum to reduce dust emission. Six. Jib counterweight. At the tail end of the boom, one counterweight box is provided. Seven. Operator cabin. Eight. Raking harrow. A raking harrow is mounted on the bridge reclaimer, which rotates anti-clockwise, around the central column, for steady reclaiming of the material, from the slope of the pile. The harrow is provided with raking teeth, of steel which are connected by bolting. Nine. Raking car. Raking car is installed in the raking harrow, responsible for the raking harrow movement. 10. Scraper chain. The sweeping movements of the harrow system cause the material to slide to the base, where the chain system then conveys it to the centrally placed outlet hopper. (11) Hydraulic chain tension unit. The tension carriage is centrally arranged below the bridge, and is provided with Belleville cup springs. The tensioning of the chain is provided by a grease-filled hydraulic cylinder with manometer for supervision of the chain tension. (12) Bogie. The bridge-type reclaimer collecting the material from the front of the pile incorporates a heavy radial bridge as carrying structure connected to the center column, and the head girder with its bogies traveling on the circular track around the stockpile. (13) Outlet hopper. Below the bridge and in parallel with the base and the face of the stockpile, the scraper chain conveys the material radial to the central hopper located below the center column. 14. Outgoing belt conveyor. The homogeneous material leaves the store by an underground rubber belt conveyor, leading either to a hopper or direct to, for example, a cement raw mill. Thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.